Okay. Okay, so we did the diagrams on the curved mirror. Will pop up in our screen here. And what we're going to do today is look at the curved mirror lab and what execution that we're going to do. Okay, so here we go. Okay, so this will be curved mirror. Okay, so first thing, I got a couple of labs here for you guys to hand back. So let's do that first. And then we'll go through what we're going to do on the curved mirror lab. I'll explain a couple things to you in terms of what we need to do. I'll just pause this for a second here. Okay, so I'm just going to quickly go through what our objective is, okay? So our objective is to verify the curved mirror equation That's all we're going to do. So what we need are the following things. So the materials that we have, and they're all in the filing cabinet there. We need a concave curved mirror. Okay, we also need a mirror holder. We also need a measuring tape or meter stick. Probably a good idea. I'm not sure if we're going to need more than a meter stick, but probably we will. Okay. We also are going to need a piece of white paper and a candle. To help us out as well. Okay, so our setup is pretty simple. Okay, our setup looks like this. So what you're going to do on a flat surface somewhere is you're going to set up your curved mirror. Okay, here, and then you're going to have your meter stick. It's going to be in your holder. And then you're going to have your meter stick. Okay, it's going to be there. And then you're going to have your candle somewhere here. Okay, now you have to make sure that the candle flame and the mirror are on the same level, or it won't work. Okay, and then you're going to have your paper somewhere along here. Depending on, this is where to find the image. Okay, so this is going to be your object distance. This is going to be your image distance. Okay? And the focal length we're going to figure out at the beginning. Okay? So what we're going to do is we're going to experimentally find image distances and compare them to where they should be according to the equation. So that's our theory. Okay? And you're going to do this for various distances along this meter stick. Okay, so we'll set up a table here in a minute, but the theory is that we will measure the image distance and calculate the image distance and see if they agree. For many or different object distances. Okay, so where do you go? Where does the object have to be in order to get a real image? Okay, so somebody remembering their diagrams, where if the object has to be, if it's inside the focal length, what kind of image do we get? Do you remember? That was Thursday, so that's a little while back. Okay, this is kind of key to this lab. Where are we only going to get the real images from? Go ahead.
Would it be in front of the mirror?
Right, so you have to have the candle in front of the mirror, but in terms of if we put it really close to the mirror, are we going to get a real image? Think of your diagrams. No, the only time you get a real image is if the candle is beyond the focal length, right? If it's at the focal length, there's no image, right? Situation D, I think. And if it's inside the focal length, we get a virtual image. This is for a concave mirror, right? So the key is real images for, sorry, not for, if, form. If the object is beyond focal length. Okay, so you will not be able to do tests for objects that are beyond the focal length. And I think I'm going to get you guys to do 2 or 3 tests. Well, let's do more. Let's do 4 or 5 tests. So it has to be beyond the focal length. So I'm going to explain how you get the focal length of your mirror, and I'll demonstrate it here so that you can see it. Okay? And it really, 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 really helps if we find a nice dark room somewhere. So we're going to go find a nice dark room. Okay, so here's the directions of the process. Okay, step 1. Okay, you're probably going to work with a partner on this one because one of you guys is going to have to hold and one of you guys is going to have to measure things. So step 1. All right, first thing that happens is focus a faraway object, light source, we'll say, like the windows, onto a white sheet of paper. Okay, so on a white sheet of paper, the distance from the paper to the mirror is the focal length. That's the first thing you have to do. Okay, record. Okay, I think ours are either 20, 25, or 30 or 35, something like that. So it's not going to be, the really short ones we're not going to use here. Okay? Well, we could try the really short ones too. After you've done that, you're going to place or set up the equipment, we'll say, sorry. I'll demonstrate this today. Set up the equipment. Except it's spelled wrong there. There we go. And place the candle, which is representing our object, at various distance beyond the focal length. Okay, various distances beyond the focal length. Okay, record and then find the image on the paper. And record the image distance. Set up the equipment, place the candle at various distances beyond the focal length, find the image of the flame on the white paper, and record the distance. Okay, so you should do, I don't know, 7 or 8 different ones. Okay. Then pre-calculate what each image distance should be using the equation. Okay. And 4, compare each image distance that was measured to each image distance that was calculated. Okay. So I'm going to demonstrate this to you today and show you how to do all these things. Okay, and then I have 2 mirrors that will work for this one. I used to have 3, but one got broken a couple weeks ago. And we're going to use these 2 mirrors, and I'm going to show you how all this stuff works. And we're going to set up a table here. But we're not going to set up the table until I show what I want you to do. Okay, so we're just going to demonstrate a couple of things here, and then we'll go from there. All right, so we're going, after that demo, we're just going to do our table of data.
Can we turn the projector on?
So actually, I should probably do that, yeah. I forgot I turned it on. All right, so what we're going to do, I think what we'll do is, because it's a 35 centimeter focus, is we'll do multiples of 10s. Okay, we did an example of 50. So what we have to do is we have to have here in our table First one we're going to have is candle distance or object distance. Okay, and then what you're going to have is the measured image distance. And then the last one is going to be your calculated image distance. Okay. And then, of course, we have a focal length up here of I think it's 35 centimeters. You said 36 and 38, right? So I know they're supposed to, so it could be 40, but we'll go with 35 centimeter because that's what it looked like. Okay, so our object distances that you guys are going to use is you're going to do 40, 50, 60, and then let's go 80, 100, 1, 2, 3, 4, 5, 125. Let's do those 6 distances. Okay, so do 40, 50, 60, 80, and 125. And what do we get for our 50? 106, right? For our measured distance? Okay, but yours will be a different. Okay, so let's do the calculated image distance. Okay, so I want you to do these 6. 1, 2, 3, 4, 5, 6 measurements tomorrow. Okay. And then the calculation one, you would go 1 over di plus 1 over do equals 1 over f. Okay, so in our case, this f was 35, so 1 over di would equal 1 over f minus 1 over do. In our case, we get 1 over 35 minus 1 over 50. Okay, common denominator between 50 and 35. Would be 350, right? So this would be 10 over 350 minus, how many? 7 over 350. So this would be 3 over 350. And then 1 over di would be equal to 3 over 350. So di would equal 350 over 3. So that should be what? 350 divided by 3 is 116.7 centimeters. So I'll say 117 centimeters. How close were we? Well, let's see. We got 106. It's supposed to be 107. If we do a percent difference, that would equal 117 minus 106 over 117 times 100. We equals 11 over 117 times 100. Hey, not bad. 9.4%. That's pretty good. If I would have focused it a little bit better with the paper, we might have been a little bit closer even. Okay, so what I want you to do is I want you as pairs to do those 6 calculations and those 6 measurements and those 6 comparisons. Any questions? Pretty easy, right? Where are we going to do it? Well, we can do one in the change room there if there's nobody in there. But if there's too much light from 2 groups in there, then we could move another group to another dark room somewhere. But I think you can get 2 rooms. You put one person in the shower, whoever wants to sit in the shower area and do it. Right? You'll have to flip for it. Okay, so that's what we're going to do tomorrow. So that tomorrow will be just recording your data, coming back to the room. It'll take you 15, 20 minutes to record your data. Come back, do your 6 calculations, which you could actually do now because you know what distances you're going to have. And then do your percent differences. And then you're done. Okay, any questions before I say that's it for physics today? Okay. So that's what we'll do tomorrow.